Okay, let's start with our problem statement. You are on a target range preparing to shoot a new rifle when it occurs to you that you would like to know how fast the bullet leaves the gun, that is, the muzzle velocity. You bring the rifle up to shoulder level and aim it horizontally at the target center. Carefully, you squeeze off the shot at the target, which is 300 feet away. When you collect the target, you find that your bullet hit 9 inches below where you aimed. Okay, let's focus the problem, and let's just kind of draw a picture of what's going on. We have a rifle here. It's 300 feet away from the target, and we know that we're aiming level. And by the time it hits the target, the bullet has dropped 9 inches below where it would have hit if the bullet had traveled levelly. So what's the question? Given the drop, what is the velocity of the bullet exiting the rifle? Now, our approach is, since the bullet is in free fall, the time to drop can be calculated since it's constant acceleration, which is the same time for the bullet to travel as 300 feet. Let's describe the physics. We have an object which has some velocity dB at position y0, at time t0, and horizontal position x0. It winds up at position y1, x1, and t1, where y0 is the initial height, 9 inches. y1 is the height the bullet drops. x0 is the initial position, minus x, or x-axis. x1 is the final position along the x-axis. vb is the velocity of the bullet, t1 is the time for the bullet to strike, and t0 is the initial time, which is 0. Target quantity, or quantities. We are after only one here. We're after VB, the initial or the velocity of the bullet exiting the rifle, or muzzle velocity. What quantitative relationships do we need? Well, we need the time for the fall and the muzzle velocity. That means we have two quantities we have to solve for. We have one quantity relating the time of fall, t1 minus t0, to the height of fall. And we have another quantity relating the velocity of the ball, or the bullet, to the time of travel and the displacement. Let's now go to planning the solution. When we start this process, of course, you want to start with an equation that has the target quantity. And the first equation I start here with is x1 equals 0 plus vd quantity t1 minus t0. In other words, the final position is equal to the starting position plus the velocity of the bullet times the change in time. Then we ask another question. Is there another relation that contains t1 minus t0? Yes. We wrote it down previously, that the final height is equal to the starting height minus 1/2 the acceleration due to gravity, or due to the force of gravity, times the change in time squared. Well, that means we can solve for the change in time squared as shown here. And then we're going to take this quantity, since we now know the time, and we can bring it back and substitute it right here in this quantity. All these are now known quantities. So we solve for this VB in terms of all these quantities. We get the velocity of the bullet is equal to the change in position along the horizontal axis times the square root factor. Now we have our equation. Let's now execute the plan. We're just going to substitute our numbers. We know that the horizontal change in position is 300 feet. We know that the acceleration due to the force of gravity is minus 32 feet per second squared, and that a 9-inch drop is 0.75 feet, and we can substitute those quantities, and we find that the velocity exiting the rifle is 1,385 feet per second. Evaluate the solution. Yes, the answer is properly stated. No, it is reasonable. We do expect a high velocity. Yes, nothing else was asked for in the problem.